Finally, we enter our relative perm data. Relative perm data is something we really rarely have. In this case, the only thing we know about relative permeability is we think that it's probably water wet, and we're given an oil or a connate water saturation of 30%. So we'll use default values and set up for a water wet system, and then specify our connate water saturation as 30%, and we'll perform our correlation. This may be rather rough. From analogy data in your area, you might decide that the water curve probably should go up higher. Where here it went up to 15%, we want it to go up to a fraction of 25. So we'll increase the endpoint of our water curve to 0.25 and tell it to recorrelate, and you'll see the water curve move up. Next, we might decide that the curve really should come down a little faster and be lower in this area. So we can change the shape of the curve by changing the exponent for the water curve, and you'll note that the curve will go down when we recorrelate. So you can adjust the shape of the curve to fit what you think your data ought to be. Merlin is used at the University of Texas, and one of the professors there recently told us that his students learned more about relative permeability curves playing with our program than he had been able to teach them in a 2-week period. We have now described the complete initial state of the reservoir. Notice that there has been no magic data. Any of the data that we've discussed is data that if you understand how reservoirs function, you can understand what we are doing. And you could pick the same sort of data for your reservoir and build a model of your reservoir.